So in this next section we're going to explore the capital asset pricing model, or Capm as it's more commonly known in the industry, which is a mathematical equation that uses beta in an attempt to predict what an investment may achieve in the future, and that is known as a theoretical expected return. Sometimes in RO2 you will see this phrase used, this theoretical expected return, and they're expecting you to recognise that they are talking about the capital asset pricing model when using that particular theory. So the whole idea of capital asset pricing model, Capm, is to essentially calculate the expected return that you should get for the level of risk that the investment you are taking. And what it tries to do is not to be over reliant upon the past performance of the investments in trying to predict the future. It actually uses the market return of the investments, so the benchmarked return, adjusted for the additional risks or lower risks that an investment carries through its own beta. So there are a number of assumptions it makes essentially, but we're going to need to learn the mathematical calculation, which is shown on the slide in the little graphic to your right hand side as you look at it, which will introduce the concept of risk-free returns, market returns, and of course the beta of the particular investment. I think this is one of those matters that's easier really to understand when you start to look at the maths, and we're going to break it down, look at a couple of examples, and hopefully from that you'll feel in a far better place to answer questions on Capm in your exam. So let's look at the assumptions first that Capm makes in arriving at the figures that you've got. Will you need to learn all of these? Probably not, but it's useful to have these in the background at a high level understanding. So Capm assumes that investors are rational and risk averse. Are they? Well, only time would tell. I'm guessing that not everyone would be, but most are, I suppose. And that investors make decisions on risk and return alone. And what I think we mean by that is that sometimes investors have more pressing matters to consider when investing rather than risk and return. A classic I can give you on that one is they may have strong ethical views. It assumes that all investors have the same holding period, as many buyers and sellers. No one in isolation can affect essentially the market position. So they are all assumptions made if this model is going to work, and it's certainly come in for some criticism over the time. So we'll concentrate more heavily on what the actual model is and what the actual calculation is, as opposed to these assumptions, because that's where you're more likely to be faced with exam questions. So here we have it then. Here is the capital asset pricing model formula, and we have the ERI equals RF plus open brackets beta, open small bracket RM minus RF, close brackets, close big brackets. And my gosh, doesn't that look appetizing? It's a horrible formula, and generally speaking, most people see that and think, well, my word, am I going to remember that? Well, let's break it down. Let's see if we can find a way, shall we, that we can work this out and remember this easier than just remembering the formula. But I think we need to understand what each of the particular letters mean. So we are ultimately trying to create an expected return. That is the ERI. And it basically says that the ERI is the expected return is a combination of the risk-free plus the adjusted for risk by beta market return that the investment finds itself within. So RF is the risk-free rate of return. Treasury bills are largely used as the risk-free return. The beta of the investment, of course, is the measure of risk of the investment sensitive to its market, and the return on the market is what the actual market has achieved by way of performance. Ultimately, what we're going to do is we're going to combine the risk-free return with the risk-adjusted market return. We're going to add the two together to give us our expected return. So let's look at an example then, shall we? I do genuinely think that this is easier to learn through the maths. And we've got a question that's asking us to calculate the theoretical expected return on a security that has a beta of 1.3, where the market return is 7 and the risk-free return is 0.75. So before we dive into the maths, let's just again reiterate what these figures and numbers are telling us. This is basically saying that the market return, not the investment we're looking at's past performance, but the market return by which it was compared to, is 7. And it's saying that our investment is more risky than that market at 1.3. So we would need to adjust up expectations to take into account the added risk that our investment is carrying. All investments have an element of risk-free return within them. So effectively that's quoted at 0.75 on this particular example. What we're going to need to do before we risk adjust is we're going to need to remove that from the market return. Otherwise we'll be risk adjusting something that is risk-free. So we're going to isolate the risky element of this return, the market return. We're then going to multiply that by the beta to adjust it up for the additional risk that we're taking. Adding the two together will give us our Capm figure. So here goes, let's look at the numbers. So the first thing that we're going to do in this particular situation is look at the left hand side, which is our official formula, and show you how this particular thing works. So you can see the formula stayed out in front of us, and we're going to fill the numbers in along the way. So we're going to have the 0.75 as the risk-free, and we're going to add to the bracketed beta multiplied by the risky element of the return, which is 7 minus 0.75, 6.25 essentially is the risky element. So there are two different blocks of return that make up that market return. The risk-free element of 0.75 and the risky element of 6.25. We will adjust the 6.25 up because our investment is more risky than the market. 0.3 risky actually, which we know is 30%. So if we multiply 1.3 by 6.25 and we will get 8.125, add back in the 0.75 for the two elements of return, we get 8.875. So the theoretical expected return of this particular investment is 8.875%. Now on the right hand side, I have also shown here a somewhat easier, in our eyes, way of doing this and way of calculating this. And that is to not remember the formula, but to remember risky times beta plus risk-free. And that's got a certain ring to it, I guess. Risky times beta plus risk-free. So work out the risky element of the return by taking away the risk-free from the market return. 7 minus 0.75. The risky element of our return is 6.25. Multiplied by beta, 1.3, and add back in the 0.75. You get exactly the same answer, 8.875%. Essentially, what that means is you have an option. Two options. Do you want to go the mathematical route of remembering it or the nice easy route? We're not really fussed which way you take in the exam, as long as you can calculate Capm, because you are very likely to need to calculate Capm in your RO2 exam. Just like with the efficient frontier, the capital asset pricing model has had its critics over the time, and just like the efficient frontier, it essentially has limitations that we need to recognise, flaws for want of a better phrase. And as we've been through adverse market conditions on a number of occasions in the last few years, the capital asset pricing model has been found to be flawed. But in the absence of anything else, it continues to be the one that is most commonly used. So the biggest problem with Capm is considered that not all non-systematic risk can be removed from diversification. Of course, correlations are constantly changing of investments. Betas are historic and unreliable, and also it's very, very heavily weighted on that beta. The beta, which adjusts the market return, if that's slightly wrong, then we're going to get a slightly different and slightly incorrect prediction of the returns we're going to get. So there are alternatives to Capm. We're going to look at those in the next section, which essentially are the multi-factor models, which have been developed over time. And we're going to look at Eugene Fama and Kenneth French's various different takes on this and what they came up as an alternative. But I have to say, they are essentially variations of a theme.